The other way we passing the pointers through the function, they will work like you passing an array through the function. So we have already worked with something similar to the pointer, like we passing the array. So we see what they look like. Remember before, when we want to show values function, we can pass in an array, for example, called numbers. Then the size of the array numbers. Then we can display the whole content in a for loop for the numbers array. So that's how we will call the function. So this function we implement a couple times. Remember, because we are trying to display the content for the array, so we are not trying to update the data. So that's why we have the const keyword to show we will do the read only. So that's why here in your show values function, you pass in the function header is the int values array. Then you can pass the size. So this one actually the same thing. We can rewrite this one as a pointer symbol. So the pointer, when you pass in the PTR, just like you just pass in the array name. And also the same thing here, when we do the constant keyword, they also can work with the pointer as well. So when you pass in a pointer as a constant pointer, that's the same thing mean you only passing by read only. So through the PTR variable, they only can read the data when they pass in by the address, but they are not allowed to update the data. So the first thing we just see again in the memory location what happened for the show values. For the show values function, you can see here is our show values function. We have the for loop. We can access the index one by one to display the content of the array. So here, don't forget, we need to add the constant keyword. So this one, they're missing the constant keyword. So here, you should add the constant keyword for your values. So when you pass in by the constant keyword, right? So this address, the values, actually only the values, they have the address. So when they pass in is, when you have your main function, you have the numbers array. You call the function, you pass in by numbers variable name. So then this address will be holding, but in the local function, we refer by values keyword. Not the values keyword, the values variable name. So that's why here, let me add the values here. So this one actually, so you see your local variable, you have values, array name, right? And you also have the size. Okay, so this one is the size. But because the size, you see the local function, we're using the lowercase size as a variable name. But when we have the function code, we pass in by copy, right? So the size, for example, is 5. We pass in by copy. So this 5 actually is holding in the local function. So refer by the local variable size. So then you have values. But these values, when they call the function, the numbers array, they will pass in by the array address. So that's why whenever we access, we actually is passing back to go back to the main function where the numbers array is. So then we can display one by one. So this one you can either using the array name, but just like we say, array name actually works exactly like the pointer. So actually you can either write like this, you pass in the array name as the local function array name is values, or we can just using the PTR. So when you're using the pointer as your function header, so then this PTR will work like your array name. So then we can see the example from the example 13 to help you to see how they work when we just display the array. So this array we want to display, we just call the pay rate. We just say, for example, we have 6 employees. So these 6 employees, they have their hourly pay rate. So we have the double array. So then you can see I have 6 numbers. So then the function, when we want to display the pay rate, we pass the array name, we pass the size. So this one before we passing by array, right? But now we show you now your function actually can pass in by pointer. But this array is double array. So your pointer should be double data type pointer. So then for the pointer, you also can add the const keyword. So if you have const keyword, that means you only passing by read only. So you passing by read only, you see here we have our pointer name called rates, right? So this rates will holding the memory address of the pay rate array. So then here we can display the pay rate for each employee. So we use the count as the index. So then you can see here, because that's the pointer, so you can use the pointer to add the offset. So then we do the parentheses to dereference. So then you can have your result. So that's how we were using the pointer passing through the function. They will work just like an array. Of course, I need to make sure you run this program on your IDE. So that's why after you run your example 13, so then you can see when we display the output, they do have all the employee salary. So then you can see here, we passing the array. When we call the function, we passing the array name. But in your function prototype, we can, instead using the array symbol, we can just using the pointer. So then when this pointer, they can either using the dereference plus using the pointer arithmetic to add the offset, then we dereference. Then we have the result. Or you can see here, I have the note. When you have your pointer variable name plus the offset, then you do the dereference. Actually, they just work like your pointer name can be array name using the square bracket. Okay, so that's try here. Let me comment out this one. Maybe we just copy again for this one. For this time, we copy again. So then we don't using the pointer dereference. We can just using this pointer name, then using the square bracket. Then your count is your index, right? So then you can see here, pointer work exactly just like array. So then we run the program again. The internet is slow, so that's here. Yeah, then they got the result. So you can see here, when you have a pointer, you can either work the pointer using the dereference with the pointer arithmetic, or actually your pointer just works exactly like your array. So after you understand the pointer you passing by reference, just like you work as an array. So that's I want you to review more from what we have before. Remember the last couple weeks, we tried to pass in the array through the function. So now can you change all the array passing through the function using the pointer syntax? For example, using the sort function. So when we have the sort array function, we pass in by array name. So then we have the size. So remember, if we want to have ascending order, then we just have the nested for loop. Then you can have compare. If the j value is less than the I, we need to swap. So the swap, we either show you the swap function using the reference, or you can see the swap function actually like this. You have a temp variable. Then you have your j to temporary holding in the temp variable. Then we can have the I index value to assign to the j. So since j already been overwrite, right? So then earlier, that's how we save the temp value. So then we can reassign to the I. So that we can have the index I and j value being swapped. So this one actually, before we write, the function actually is in the array passing by array in the function. So now, can you pause the video? Can I just simply change the function become a pointer syntax? Right, we can, right? So when we try to sort array, so then here is numbers can be the array name, but actually this one just will work like this. You can see I'm on purpose, I didn't change the variable name. I just still using, before we using the number array. But how about this number? I just using as the pointer variable name. So when I change my function header like this, actually, oh my, function content, I didn't change. Because when I have the numbers as the array name, they just work like a pointer variable. So I can using the pointer variable associate with the square bracket operator to do the comparison. So then you can see from this slide, the function content exactly the same. So the only thing different is the numbers is not array name anymore. It's just the pointer variable. They are exactly the same. We can do like this. Or if you like, of course, you see here, I can still using the numbers work like a pointer. I do the plus J to get the offset. So then I do the dereference. So then I compare the value. So then when I do the temp swap, I still using the dereference. But one thing is, like I say, here we want to show you is, when we passing the array by reference, they just work like your pointer. So sometimes you can see, sometimes the function prototype, they're using the pointer, but actually they can passing by array. Even I'm using the pointer name. Okay, so this one is for the ascending order. So of course, for the descending order, we can do the same thing. So even you passing by the array, but this array name can totally change, just become the pointer. Just one thing is the data type should be the same. So this one is the example we're using the pointer to replace the array name. So your pointer works exactly like array name. The next one I also want to show you is, right, we have our swap, right? But can we write the swap function, the same thing, as the pointer? So why I say that is because why I need to using the swap function. So the swap function, instead of we always using this three line, since we call swap, we do the swap action a lot. So can we just write a swap function? You give me two value, then I just swap their value. So right, so this one actually the swap function, before we show you, maybe you can write as the reference. But the swap function we also can passing, using the swap function we write as passing by pointer. Because your x refer to the argument you pass. The y refer to the argument you pass. So you can either using the reference to write your swap function, but also the swap function can write in the pointer argument. So when you do like this, you will still need a temp is the int variable. So then we have our value from the x, right? Because you passing by the pointer. So if I want to get the value, I need to have the dereference. So this dereference is will get the value we're passing by. So we assign the value to temp. So then we have the y value assigned to x. So then we have temp value assigned back to y. So when you passing, using the pointer to passing the variable, so how you will call the function? When you call the function, actually they look like this. Don't forget, for example, that's in the main function. In the main function, if you have num1 and num2, so when you want to swap, don't forget you need to have your ampersand when you call the function, because now the function actually is we passing by pointer. So that's how you will call your swap function. So one thing is this swap function, so how we will be called.